This is the dashboard on the driver's side. In this part, the windshield will be fixed, and here there will be a handle. The windshield bracket and handle parts are not yet complete. So we will replace the windshield with a paper for explanation. If you look down, there is a projector. This projector, which is based on the below, will create an organized GUI image into this windshield. You can perform many control functions of the car with just one click. And all clicks are done in this mid-air, not by direct clicking. We can use lip motion to recognize our fingers and dabbing of our fingers. And Ultra Haptics below will provide different feedback on the user's finger whenever we click on the button and the image of the windshield.
Nowadays, the automotive industry is struggling with air drag reduction. Less air resistance increases fuel efficiency and driving range. Traditional door handles that provide an additional air drag are being replaced by auto flush door handles, where the handles are moved out from the door when driver approaches vehicle and pulled in while driving. In our project, we aim to completely remove door handles. We propose to simulate a push latch effects on the door, which is familiar and intuitive to drivers. For example, sunglasses compartment in vehicles usually utilize push latch mechanism. A push latch mechanism provides two types of haptic feedback: a compliant motion of the door that shows to a user that process is going on, and vibrotactile clicking effect at the end of the motion signaling that the door is unlocked. When the user closes the door, a spring mechanism of the latch turns to the ready state. We simulate the comp-line motion by a closed-loop modulation of vibrotactile feedback with respect to contact pressure. The clicking effect is synthesized in an open-loop fashion. The proposed system consists of three hardware components. First component measures a contact pressure using multiple strain gauges attached to the inner side of a door surface. While a user touches the door, micro deformations of the door surface changes the resistance of strain gauges, which can be detected using a windstone bridge. In order to convert the raw signals captured by strain gauges to meaningful physical units, we developed a black box data-driven model. We collected contact forces at 16 locations using a custom tool equipped with force sensor, and trained a radial basis functions network mapping signals from strain gauges to normal force of a contact. Pose 3 vibrotactile patterns. First, the intensity of vibrations linearly increases with respect to contact pressure. The period between pulses is modulated with the constant vibration intensity. Third, both the period between pulses and the vibration intensity is modulated. When the contact pressure reaches a predefined threshold, the clicking effect is played back and the door opening system unlocks the door. Before the demonstration, we will perform the psychophysical experiment where we determine the optimal vibration pattern. During the demonstration, attendees will be offered to experience the system either with optimal or all three vibrotactile patterns.
Hi, I'm Domenico,
And I'm Antonio.
the Italian team from the Scuola Superiore Sant'Anna. We are here to show you our novel product.
Maybe you don't know, but in Italy we really love driving. And when I say driving, I mean being able to use the gear knob, the clutch pedal, and all this old-fashioned stuff. We have asked to some of our friends.
200, I would say.
What type of car will you buy in future? And most of them confirm their preference for the manual gear system.
Anyway, there are some wrong behaviors that makes our new car life shorter, like touching the gear knob or pressing the pedal when if not necessary.
For this reason, we have designed an automotive haptic system that, on one side, improves the driving experience, while on the other, it helps the novel driver to learn to use the manual gear system.
If we made it, you will judge it. But at least we have learned that the Italian market is ready for this kind of device.
In the future life, artificial intelligence technology will be deeply embedded in the future car. It will brings great convenience to people's travel. On the one hand, the in-vehicle eye system can provide navigation information for the driver. On the other hand, it can provide a road condition warning when the driver is out of driving loop, requiring the driver to resume driving. Our vibrotactile wristband can transmit information to the driver speedily, effectively assisting in driving while reducing driver's information load on the visual and auditory channels. The vibroband consists of the wristband part and the IC part. There are 6 vibration motors attached on the wristband. The IC part is composed of Bluetooth module, MCU module, driver module and power module, which are fixed in a 3D printed box. In this part, we will show how to wear the vibro wristband. In this part, we will show how the wristband works in our demo. Order no signal. Order turn left. Order bad road condition. Order can't navigate. Order turn right. Order obstacle. Order pedestrian. Destination is ahead. Based on our work, in the future, we may add more sensor into the wristband to get the information about the driver. What's more, our IC part can be connected to other actuator, so we may develop a other motor system based on the IC part.